Example 8.6 actually requires two steps or sort of two stages. So I'd encourage you to make a note that this is a two-step problem, and you will encounter problems similar to this in structure on the web work. So let's read what the problem says. It says air pressure decreases exponentially as altitude increases. So I can tell right away that my dependent variable will be air pressure, my independent variable will be altitude. It says at an altitude of 1,000 meters, air pressure is approximately 90 kPa. I believe the unit for air pressure is killer pandas, so that's what this kPa represents. At an altitude of 1,950 meters, the air pressure is only 80.5 killer pandas. What is the approximate air pressure at Humphreys Peak, which is the highest point in Arizona, which has an elevation of 3,852 meters? I'm going to start by taking the information from this first sentence and just trying to capture that through not exactly a timeline, but a simple display that shows the altitude and air pressure volumes that are provided in that first sentence. When I reread the problem, I notice that there is no growth rate, or in this case, decay rate, provided in the problem. And yet, this information will enable me to solve for such a growth rate or decay rate. And so the first thing I need to do is to use this given information to solve for R. In setting up my formula, I will use 80.5 as the final value, and I'll use 90 kPa as my initial value. And it's important to note that when I make this choice, I have determined 1,000 kilometers to be my reference point. And so my x, which appears to be measuring altitude, will actually be measuring altitude above that baseline value of 1,000 meters. So in order to catch the relationship between these two given quantities, I actually note that I have an increase of 950 meters from my baseline of 1,000 meters. So that's the x value that I'll plug in. As stated, my goal for the first part of this problem is to solve for the rate. Plugging these values in yields an equation whose structure is very similar to the previous problem. So I'll use similar steps to solve for the rate. So these calculations yield a very small negative rate. The negative sign makes sense because my quantity is decreasing. And I've seen a decrease of about 9.5 for an increase of 950. So it makes sense that this rate is pretty small. For the second part of this problem, I will now use that rate to calculate the altitude at Humphreys Peak, which has a specified to calculate the air pressure at Humphreys Peak, which has a specified altitude. Note that I'll use the rate that I just calculated, and then recall that my x is measuring the altitude above a baseline of 1,000. So the altitude of 3,852 will actually translate to an x value of 2,852 because that is 2,852 meters above my baseline of 1,000. Plugging these values in and simplifying, I get a final value of approximately 64.387 killer pandas. So the air pressure at the top of Humphreys Peak is approximately 64.387. In the final example, we're going to contrast properties of two separate models. The context is two job offers that you're given upon graduation at NAU. Both companies offer a starting annual salary of $34,200. One company guarantees a raise of $850 every year, while the second company guarantees a raise of 2.25% each year. In the course pack, there's a table provided for you to do some calculations. I'm going to actually do the calculations in a spreadsheet program and then reference the questions that are asked in the course pack. But for the rest of the example, I'm going to switch over to a spreadsheet program and implement the calculations in this format here. So in both companies, starting salary is $34,200. So in my table, I can input $34,200 as your year 0 salary. At Company A, your salary will increase by $850 every year. In order to implement that in the spreadsheet program, I'm going to start with an equal sign. I'm going to take the previous year's salary and simply add $850 to it. So after 1 year, your salary will become $35,050. If I want to then project that salary forward, I can simply paste that same salary calculation for the subsequent years. Just to check that the spreadsheet is doing what I want it to, I can pick an arbitrary cell, click on the formula, and that does show me that to calculate the salary in the 7th year, it's taking the 6th year's salary, the previous cell, and adding $850. So that's a quick way to project the salary at Company A over the first 10 years. At Company B, raises will increase by 2.25%. So in order to implement that in my spreadsheet program, I can take the previous year's salary and add to it 2.25% times that previous salary. So what's different here is that there's not a fixed dollar amount by which your salary would increase every year at Company B. Instead, there's a fixed percentage amount. And that's this 2.25%. So I'm going to take last year's salary. In this case, that's represented by the cell C3. And then I'm going to add 2.25% of last year's salary. Once again, once I've implemented that calculation in the first cell, I can project it forward in my table by just dragging that formula down. These values are a little strange because I've got too many decimal places, and so let me just modify the formatting. And now I can use my table to project any number of years into the future. Let me just look quickly. It looks like in year 5 at Company A I'll be making $38,450, but at Company B I'll be making $38,224. The problem in the course pack asks me to project to year 13, so I can extend the values in my table easily. And if I was to look specifically at year 13, at Company A I'd be making $45,250. At Company B I'd be making $45,671. And it actually looks like it's in year 10 when the salary at Company B overtakes the salary at Company A. In fact, I could add an additional column which calculates the difference between these two salaries. And you'll notice that in year 9, Company A offers $67.35 more than Company B, but in year 10, Company B's salary takes over. So now Company A's salary is $22 less. Example 8.7 also asks us to consider the cumulative amount that you have made at each of these companies over the course of the time period that we're looking at. I could do that calculation easily in a spreadsheet. Let me insert a new column to the left of each of my companies. And then starting in year 1, let me do a calculation which will calculate the sum of the first 2 years' salaries. In order to make this formula structured in a way that I can just drag it down, I actually want to fix this first cell. That's the cell B3. So for that cell B3, I'm going to add dollar signs to the cell reference. And then when I drag that formula down my table, I'll be able to, it will fix that first cell reference. Let's project that forward over all 13 years. And let's create a similar calculation for Company B. These numbers are pretty large, and it's hard to kind of take in exactly what these values are showing me. So let me do, just label the data that I've created here. Let me do one more calculation. This is the cumulative for company A. This would be the cumulative for company B. This is the raw difference. And then this is the cumulative difference. So in this column, let me again subtract the values for company A and company B. This time, let me do a subtraction of the cumulative values. So over the course of the first 2 years, company A has given a higher salary of $80.50. If I project that forward, it's kind of interesting. Here we saw that here in year 9, between year 9 and year 10, the actual salary for company B takes over the salary for company A. But if I look in year 10, cumulatively, over the course of those first 10 years, I've still made over $1,000 more at company A. One benefit of setting this calculation up in the spreadsheet program is that I could continue to project these calculations indefinitely into the future. So let me project for a few more years. So we can notice, for example, again, this last column is the cumulative values and the difference between the two companies. It's not until year 15 in which the cumulative salary for company B finally takes over the cumulative salary for company A. In the course pack, there's a few specific questions about which job you would take. There's obviously a lot of considerations, but these calculations help us get some sense of how the two raise packages compare over the course of the first several years working there.